Hello everyone, in this video I want to talk about the chain rule. The chain rule allows us to differentiate many more functions because it allows us to differentiate, as we'll soon see, compositions of functions in other functions. So here's what the formula says. It says big F of x is equal to little f of g of x, and f prime of x will thus be equal to f prime of g of x times g prime of x. Now, you could see this deals a lot with functions in other functions, and I'm going to give you a brief review of what that means. So, let's say we had f of x is equal to 3x, g of x is equal to cosine of 2x, and the question's asking, what will f of g of x be? Well, it's pretty simple. What you do, you take this whole g of x function and you substitute this into the x over there. Doing that, you'll get 3 times cosine of 2x. Nothing too complicated there. Now, the first example is asking, find f prime of x if f of x is equal to square root of x squared plus 1. Now, the first step to solving these types of questions is to identify your inner and outer functions. Our inner functions we'll call g of x. Our outer functions we'll call f of x. So in this example, you could see that this outer function will probably be this x squared, and this inner function will probably be x squared plus 1. So that's what I'm going to do. I'm going to say g of x, which is going to be our inner, is going to be x squared plus 1, and our outer function will be square root x. Now you're probably wondering, hey, why didn't I just do square root of x plus 1 as our outer function? Well, that's because, remember, this guy right here, this whole thing is supposed to be equal to f of g of x. Now, say I did do x squared plus square root of x squared plus 1. Now, g of x would still be x squared plus 1. So if I substitute that in, right, that'll give f of g of x is equal to square root of x squared plus 1 squared plus 1. Obviously, that's not equal to this, so that's why we didn't do that. Now, to check if you have the right composition, your inner and outer functions are right, means f of g of x is going to be square root, and then substitute g of x in, we get x squared plus 1. If these functions match, you know you got it right. Sometimes there's going to be more than one inner and outer function, but in this case, there's only one. Now, we're going to apply the formula. F prime of x is going to be equal to f prime of g of x times g prime of x. We know g prime of x from the power rule is going to be 2x. Derivative of f of x is going to be 1 over 2 square root x. If you're wondering what I did there, this is x to the 1/2. So I brought the 1/2 down, and then I subtracted 1. And if you do all that, then it gives you this. Now, f prime of x, right, it's supposed to be like this. And then we're going to substitute in g of x. G of x is x squared plus 1. And then we're supposed to multiply by 2x, right? So that gives, these cancel, you get x over square root of x squared plus 1. And this is our answer. Now the next question says differentiate a, which is y is equal to sine of x squared, and b, which is y is equal to sine squared of x. Now, these two functions are going to teach you a valuable lesson while using the chain rule. It's that messing up your inner and outer functions screws up everything. For part A, what is going to be our inner function and outer function, right? Our inner function is going to be x squared, and our outer function is going to be sine of x. I mean, you could just look at the drawing, and you'll see that is right. So we're going to have x squared for inner, and then outer is going to be sine of x. Now we can check it by plugging g of x into f of x. That gives sine of x squared. Same thing as that. Alright, so now we know we got the right things. We're going to differentiate. Is our second step. We're going to differentiate g of x. That gives 2x. Differentiate f of x. That gives cosine of x. Therefore, y prime is going to be cosine, right, of, and then g of x, x squared, times 2x, or g prime of x. And this right here is our answer. Alright, B. So, we're going to rewrite this a little. Sine squared of x, we don't really clearly see it, but we can see which ones are inner and outer pretty clearly if we write it like this. Now, pretty clearly, the sine of x is going to be our inner function, and x squared is going to be our outer function, right? Outer function is going to be f of x is equal to x squared. I'm not going to do the check. You can do it yourself, but you will see that you get this. Now, we're going to evaluate derivatives. You get cosine x, f prime, 2x. And finally, we're going to evaluate. That gives f prime of, and then g of x, which is sine of x, times cosine of x, which is g prime of x. And this is equal to, if you remember your trigonometric identities, sine of 2x. This is our answer. Okay, now we're going to move on to slightly more complicated examples. So that we had f of x is equal to sine of cosine of tangent of x, and we want to evaluate f prime of x. Okay. So the first step here, whenever you have a composition of 3 functions or more, you could see sine, cosine, tangent. We're going to have to do the chain rule more than once. Now, you might be wondering, okay, well, I know I have to take the chain rule twice, but which functions do I take it between? Well, when you're doing the chain rule more than once, always work from the outside in. And I'm going to show you what that means right now. So, since we're working from the outside in, our inner function is going to be this, and our outer function is going to be sine, right? So that means g of x is going to be cosine tangent x, and f of x is going to be sine x, right? F of g of x gives this, so we know we got it right. Now, when we evaluate our derivatives, you could see f prime of x is going to be cosine, but this one right here, we don't know, right? We don't know what derivative of cosine of tangent of x. To do that, we're going to do chain rule again, right? So g prime of x is going to be equal to, I'm going to actually just do this pretty quickly. It's going to be negative sine, right? We're going to take the derivative of the outer, and then substitute in the inner function, tangent of x, times, and then derivative of the inner, secant squared of x. Alright, now, if you go back and use the formula and do this more slowly, you could check that this is right. But for now, we know g prime of x is equal to negative sine of tangent of x times secant squared of x. Now, we can use our formula. Oh, and I'm also going to just replace this with h, so we don't get confused. Right, since it is using f of x in our current example. Okay, so f prime of x is going to be equal to, we do this, cosine of, and then we do our inner function, cosine of tangent, I know a lot of cosines, times g of x, times g prime of x, which is this. Okay, and we can simplify this a little and just pull things from the outside. I'm just going to move the minus sign to the front. And right here is our answer to this whole question right here. So, summary, when you're working with the chain rule more than two functions, you have to work from the outside in. Okay, now we're going to be doing some applications of this chain rule, right? So we're going to extend our derivatives of e to the x to more general exponential functions using the chain rule. For part A, we already know that derivative of e to the x is e to the x. Alright? Now, is there some way we can turn 2 to the x where it's in terms of e to the x, or looking similar to e to the x? Yes, there is. Now, we know 2 is equal to e to the ln 2. That is just a property of logarithms, that they cancel each other out. Now, if we take both sides to the power of x, we get that 2 to the x is equal to e to the ln of 2 to the x. Now, multiplying down the exponents, because you can do that with the exponentials, you get e to the x ln 2. And this is looking a lot more like this. But we still have to use the chain rule here, because if you think about it, this is our inner function, and then e to the x is our outer function. So that's what we're going to do. G of x is equal to, and then our inner function x ln 2. Outer function is f of x, which is e to the x. If you substitute this in here, you get that. Now we're going to take our derivatives. Right, e to the x. And then finally, we're going to evaluate. Oh, and also, I keep forgetting. So this, we can't do this because it's also g. So we're going to just replace it with h. All right. So g prime of x, I'm going to zoom out a little, is going to be f prime of x, and then we have to substitute in h of x, ln 2, and then times ln 2. We could take out this x, move it to the top, you get this, and then finally, this becomes 2 to the x times ln 2. This is our derivative. I'm going to leave the other one as an exercise for you. In general, the derivative of a exponential, derivative of a to the x, is a to the x ln a. So use this fact right here to solve part B. And if you want, post your solutions in the comments. I'm going to be posting my solution in the comments as well. Alright. So next question. I'm only going to answer part A, and then you could do parts B and C by yourself. I will also post the solution in the comments. So, let's read it. If f and g are the functions whose graphs are shown, let u of x is equal to f of g of x, v of x is equal to g of f of x, and w of x is equal to g of x. Find each derivative if it exists, and if it doesn't exist, explain why. Alright, so part A is asking for u prime of 1. So first we need to find u prime of x. From the chain rule, we know that is, right, just classic chain rule, f prime of g of x times g prime of x. Okay, now we're going to find u prime of 1. And that's going to be equal to f prime of g of 1 times g prime of 1. Alright? So, now we need to find these values. We need to find g of 1 and g prime of 1. So first, let's look at g of 1. Well, this g graph at 1 is 4. G prime of 1, right, the slope of the tangent line, that's negative 1, right? See the slope of this goes down by 1, right by 1. So the slope is negative 1. This is negative, this is positive 4, and this is negative 1. So this is equal to f prime of 4 times negative 1. Now, what is f prime of 4? F prime of 4, let's see, 1, 2, 3, 4. So f prime of 4 is going to be right here. Now, okay, sorry. F prime of 4 is going to be the slope of this line. So we need to find the slope of that line by picking 2 points. We can see it goes down by 1 and right by 4, so the slope is negative 1/4, which is our derivative. So that's equal to negative 1/4 times negative 1, which is 1/4. And this is our final answer. Again, I'm going to be leaving the solutions to the other ones in the comments, so please try them for yourself. And if you have any questions, please email me at lowqualitymathematics.com, and I will see you in the next video. See ya.